We were founded in 1957, so we're a little bit older than meetup.com. So we're a nonprofit 501c3 to promote knowledge of computing. We want to create community, support networking and hiring. We ask only a $20 annual membership. I've been coming since 2006 and it was $20 then. I guess we should look at raising our annual fee. We have upcoming talks on our meetup site and about 200 or so past talks on our YouTube channel. So we go back quite a ways. So we have 2 talk tracks, one that's kind of data science and AI, and another that's on general computing. That would be other subjects. So we're kind of in flux right now, trying different locations. Once we can kind of settle on the locations, then it'll be easier to book speakers in advance, and we can have like this pattern of the month is data science, this pattern of the month is going to be general computing. They might be at different locations. We have a Zoom audience. So if people want to send questions to the speaker, I'll be moderating those and I can ask the speaker those questions. We also have a call for volunteers. So we're a nonprofit. Just we get together once a month for a dinner planning meeting and just plan upcoming things. So there could be a variety of tasks, help with online membership, publicity and marketing, looking for locations. We could start off small if there's interest in that. So just to go around the room, raise your hand if anybody wants to make an announcement, if their company's hiring, or if they know of other interesting talks or meetups going on. I'll go from one side to another. Just raise your hand. Anything anybody wants to speak about or share? Sure, go ahead.
Hi, Dave Snyder. Just joined the chapter tonight. Also a member of IEEE, and IEEE is going to have a conference in November on AI infrastructure. I'm chairing one of the sessions. Sessions on silicon systems, applications. I'm doing one on security and standards. There is a flyer taped on the table there where you can get the website information, wts.org.
Okay. Is it on a day on a weekend or?
It's November 12th, 14th.
Okay.
Midweek.
Yeah, so we could probably cross market or advertise with you, put it on there. One way or
I have your email. I guess I will take you up.
Yeah. So because we have a monthly newsletter, I know IEEE does too, so we're happy to promote that. And if you like, we could talk about we could set up a meetup page where it directs to your registration.
Great. We could put the HCM logo.
Sounds great. Any other announcements? Job hiring, other conferences, anything coming up? So next month, I may not be here, depending on what time the month of talks are. I'll be in Spain. There's a KDD, the data mining conference moves around every year. And I'm kind of spending some more time in Barcelona. As long as I'm there for a conference, then I'll stay there on vacation. So a couple of the candidate speakers I was looking at, I found out that there was a $1 million prize, a competition for trying to reach AGI. So there was these people involved in the data set that they were promoting. I think it was an ARC data set. And so I was going to try and seek them out as a speaker because it seems like that's something that they would want to promote and how they're going to evaluate the AGI. They had interesting patterns on kind of a pixel map, and they would show by analogy, they'd have like 3 different color pixels and then show like start with 3 squares in a line and the first one. And then the second sequence is like bouncing off walls of different colors kind of thing. And that would be the completion. And it would show you like 3 examples of those and then give you one that's a query. So that was an AGI test because it wasn't language based. It's not sequence based. It's kind of image analysis, but it's not like, oh, I know what a cat looks like, so I can solve this. So it was kind of like some of the different form of problems. So that was one kind of speaker. Another is a company, Cerberus, that makes 10-inch wafers, where they execute on the entire wafer. And so I thought that might be interesting. And they specialize in AI inferencing. What's that?
I know.
Oh, okay. Then maybe you can introduce me. I'd be happy to. So I've got a list of a couple of other speakers. If anybody likes there are more chairs up front. I promise the speaker won't bite. Oh, we do have pizza here. And then there's the honor jar to tip in some cash. So obviously the $20 membership doesn't pay for a dozen pizzas a year. So if we're waiting for the speaker, if you want to go get any food, yes?
Can you talk more about the AGI? I have to come in right for it.
The AGI test? Yeah, it was something I found out. I was watching different YouTube videos on the latest going on in AI and LLM reasoning and different kinds of things like that. And so I found out that there was this group that was putting up $1 million. It just started about a month ago.
This is
No, no, it's an AGI test for like a general AI to try and demonstrate more general AI than what we have now. And so artificial general intelligence is AGI. I was giving some example test questions where it was training by analogy. And so it would give you like, here's the question is determined by here's an input and the correct response. Input and correct response. And then they give you a question that's just the input, and then you have to give the correct response. And so it requires you kind of reasoning by analogy of different sorts. I don't know if everything in the data set is testing, it's all graphical. But that was some of the things that they were showing in the short talk I saw. So, but it's trying to get into more general reasoning or general. Yeah.
A lot of the art problems are like really trivial. You look at it,
Yeah, but some of these they're obvious for people, but they're hard for current AI. Yeah.
Greg? Hello, Greg.
Yes.
So someone in chat asked, who is the contest company?
Let me look it up just a minute.
Also, are you going to make an announcement? Well, let me just read this. This facility is Valley Research Park. It is a co-working research campus of 104,000 square feet, hosting 30 plus life science and technology companies. VRP has over 100 dry labs, wet labs, and high pressure labs sized from 125 to 15,000 square feet. VRP manages all of the traditional office elements, such as break rooms, conference rooms, outdoor dining.
No, giving an announcement to the YouTube people about the complex, the location.
Oh, right. Outdoor office space and spaces.
Okay, Bill, the speaker's here. The pizza just arrived and people are getting pizzas. Motivation for Zoom audience members, if you're local, we'd be happy to visit with you.
Let me finish the announcement here.
Oh, let me get down to the speaker introduction slide. So tonight's speaker is making AI systems feel guilty. So is he waving a finger at them? LLM systems have amazed everybody with their question and answering ability. However, we don't see them as being conscious or having emotions. We describe how to create empathetic AI systems along with higher order emotions, of which guilt is an example. So Dr. Ronjon Nag is president of the R42 Group. It's an intersection of AI and medicine. He's creating a Superbio.ai, which is an AI life science app store. Also, Agemica. How do you pronounce it?
Agemica.
Agemica, thank you. It's a vaccine for aging. So I am interested in that. I try and run 20 miles a week. That's my closest.
Me too.
Holding out aging. He's an adjunct professor in genetics at the Stanford School of Medicine. He teaches on AI, genes, ethics, longevity science, and venture capital. He's been building AI systems for over 40 years and pioneered speech and handwriting recognition, mobile app stores, among many other things. So please help me welcome Dr. Ronjon now.
So happy to be here. Thank you very much for the invitation to the ACM. How many people are members of the ACM, by the way? Oh, quite a few. Yeah, quite a few. Okay. It's always very good to be a member of your professional organization. And yeah, my understanding is the National ACM, which I'm a member of. I've just joined the Bay Area ACM. That way you get the emails of interesting talks. Thank you very much for being here. This will take about 45 minutes or so, and then we will have questions and answers, but you can actually put your hand up and interrupt me in between. Some people here have known me already, but let's introduce who I am. I have really three personas. One, I'm an inventor, so I've done lots of inventing, mainly in the human computer information interface space. I'm really working on the intersection of mathematics and medicine right now. Two, I'm a teacher. So I teach AI, genes, and ethics at Stanford University. And three, I'm an investor. So I invest in AI and longevity science companies. And the universities I've been to, Birmingham, Cambridge, MIT. If you want to chat to me afterwards or even during, you can actually chat to my avatar. And it's actually cleverer than me, actually. So, but it's been trained in all of my lectures and all of my essays, and does a reasonable job of saying what I would have said in real life. The only problem is it doesn't have my jokes. That's the only problem. But maybe we need to start working on that. So I've been inventing for 40 years. My first, if you want to call it AI, I mean, I guess we called it machine learning in those days, but AI as well. That's really started in 1983. And 1983, I was working on speech recognition for phones and speech recognition for telephone digits. And did a lot of work. So my first company, Motorola, second one to BlackBerry, third one to Apple. And been working in multiple aspects of the human interface part. More recently, I've been thinking about, what inspired me, and my inspiration came from Star Trek. And of course, it's which generation of Star Trek is it we're talking about? Is it the TV series? Is it Star Trek: The Next Generation? And what's interesting is many things in Star Trek actually happened. Now, we've had the communicator, we've had the tablet computer, even the tricorder to a great extent. But what we haven't had, and this is probably what this discussion is can we actually create Android, the data, who could could provide emotions, but he's always questioning himself. Is he actually aware? Is he actually human? He was always questioning himself in this as a character. And so let's go and talk a bit more about this. This is my first speech recognition system, telephone digits, and looking at 8 kilobytes, not megabytes or gigabytes of RAM, and 1 megahertz, not gigahertz. And that's like a thing that's happened that's different for the last 30 years. Look at really 1,000, 100,000 times more computing power over the last 40 years that I've been working in this field. My first sort of commercial product I worked on was this product by Apricot, not Apple, Apricot, a British company, but it was the first laptop with speech recognition inside it, 64 words at a time, and you had to have a space in between each word. And then this is the company I sold to Motorola. It was doing cursive handwriting recognition, much more difficult than OCR, where you have nice space around each character. Each of the characters are connected to each other, so you don't know where the beginning of one character is starts, where the end is, because they're all colliding with each other. And even if you do the T cross, it's not a sequential in the characters there. You might do the T cross right at the end of the word. So that was doing cursive handwriting recognition, really using convolutional neural networks, which we'll just mention a little bit how these work. And that's me, just to prove that I have been working in AI for 40 years. This actually covers 30 years. That's me from 30 years ago. And the title is Computers That Mimic the Brain. And we're still talking about that today, and we'll probably still be talking that 30 years from now. But will it really be close to the brain? We'll sort of talk a bit more about that. And that machine is the tablet computer of the day. And we could do cursive handwriting recognition on that system. And then 3 months after getting on this cover, Motorola buys the company. And the first thing they told me to do is please invent Chinese handwriting recognition, because we've just invented texting and we don't know how to get the characters into the box because there's 20,000 of them. So we invented lots of Chinese input systems, even though I don't speak, read, or write Chinese, but fortunately speak mathematics. So what's intelligence, first of all? As we start to think about, what to create human-like intelligence, this is a little exercise I make my students go through and say, what is intelligence? And you see this little word cloud, and you see things like reasoning, context, decision-making, conscious, contextual interpretation, consciousness, think smartly, biology, curious, ability, love, right? We see neurons, comprehension, context, these kinds of things that we see in what we think when you ask each other what intelligence actually is. And there are actually other types of intelligence. Now, IQ, maybe that's how clever you are, and it's a test you can take. But there's something called EQ, emotional intelligence. That's about a 30-year-old concept. Daniel Goleman came up with that. It was basically, do you want to spend time with a person sitting next to you on a plane for 8 hours? That's different to the IQ being able to pass a test, doing mathematical answers. But we also have AQ. Do you have the ambition? Some people are driven. They may not be, quote unquote, technically clever. They may even be have not great interpersonal skills, but they may have ambition. Purpose. Do you actually have a purpose? This is something that John Gottman came up with, purpose quotient. CQ, compassion. So you may be, so there's a set of people who maybe not be able to pass the test. They may, have not as much emotional intelligence, and they're not the life of the party, but they have compassion. They have empathy to interact with other people. So usually that's linked to the EQ, maybe different to ambition. And maybe the purpose is not quite the same. And finally, freedom quotient. Can you just do what you want? No. So the current AI systems, we ask it a question and it gives us back an answer, but it's not acting by itself. So different types of intelligence. Yes.
I think it's broken out in this particular way. So how is contactable and
We'll go into that. Thank you. So the question is, we've never seen it broken out, intelligence in this particular way. Can we actually put quantification? Can we actually put mathematical formalisms around each of these? So what is artificial intelligence? Well, artificial intelligence today is not that. They're usually very vertical problems. We took artificial intelligence in the widest sense, from your robot vacuum cleaner and your iRobot. Mine still gets stuck under the sofa. Certainly we've got now language, which is related to Siri, Alexa, being able to answer questions in a much more natural kind of way. Fingerprint recognizers. My laptop's got a fingerprint recognizer. We're using AI in the widest sense, the widest definition. And usually they're very vertical problems. My chat GPT is not usually being able to recognize my fingerprint and vice versa. And so what is AI? Just to give a little definition, historically, things have gone up and down looking at the brain, looking at neurons, which is quite kind of like modern AI is based on now, neural networks. But in the 60s, that was thought to be too difficult. And so, well, how do we get knowledge inside a machine? That's known as symbolic processing, go by good old-fashioned artificial intelligence in the 1960s. Which is like trees and rules, sit a doctor down and say, why do you think this person's got type 2 diabetes? Machine learning, really numerical recipes. And the technical definition of AI, coined in 1956 at a conference at Dartmouth, was really human-like intelligence, you and me. And really, today, we're not seeing that. And sometimes that's known as AGI or strong AI, generalized artificial intelligence. The reason we say it's strong AI because we don't think any AI meets that threshold yet. So you have weak AI, which is pretty much everything out there, and then strong AI, which is the original definition. Now in the press and the literature, I mean, I think we've stopped debating it now. I mean, people used to debate, well, that's not AI, that's machine learning, or vice versa. Pretty much in the press, the academic press as well, not just the lay press, they use all these terms interchangeably. So really the cat's out of the bag. And Wittgenstein, who was a philosopher, aeronautical engineer, turned philosopher at Cambridge 30, 40 years ago, basically said, look, words are defined by the way they're used, not the way they are written in the dictionary. So basically, you can fight as much as you want. That's saying that's not really AI, but AI is now a very wide term that's used across many, many implementations, pretty much anything with a formula. And we are seeing, this is the Gartner hype cycle, which is how do innovations actually get released into the world? And the idea is you start with an idea, and then people start working on it more and more, and then everybody thinks it can make toast, and then they realize actually it can't do everything, and then people sort of get disillusioned. But then a few diehards keep working on it, and eventually say, oh, this actually works for these applications, and it actually is productive. We've got generative AI right at the top of the peak of inflated expectations right now. Is it really at the top, or has it actually gone through its entire cycle in a year and a half? We'll have to see. Yes.
Sometimes people take pictures of slides. Would it be possible to post the slides?
Of course. Of course.
So on the meetup site, in the very bottom, there's a comment section. So if you just post a link to
of course. These slides are available. We'll put a link in the comments section, and people can send me an email. My email's on every slide. That's also possible as well. And this is how do we start making machines that are guilty, that have love? And this is Sophia, the first robot that was granted citizenship. Which country was she granted citizenship of? Anyone know? Estonia over there. Saudi Arabia is the correct answer. And now what's interesting is the faces, the skin quality is quite good. It doesn't come through on the pictures, but really the interaction, the verbal interaction is very similar to what you see. I think they've added ChatGPT onto it, so it's a bit more natural, but you can tell really it's still really a machine. Now, neural networks, really we've got 100,000 times more computing power, 100,000 times more memory. These are inspired by brain-like processes. We have training algorithms. One's called backpropagation, really invented and popularized by David Rumelhart, my advisor at Stanford from 35 years ago. He wrote these two classic books, Parallel Distributed Processing, often known as PDP. One of his last projects was actually thinking about emotion. Unfortunately, David passed away about 14, 15 years ago. But that's really the core of these neural network calculations that are really used in modern AI today. So it's not like a year and a half old. It dates back like 40 years or so. And we've had great achievements. Go.
PDP book series started off my AI career.
Indeed, lots of people's careers. So they were classic books, and maybe a lot of people didn't know, but David Rumelhart and Jay McClelland, they were actually not in the computer science department, not in the engineering department. not in the mathematics department, but the psychology department. They were looking at mathematics of the brain. And that's probably one thing that's little known, I think, is when I was starting my work there, and I did my PhD in engineering, looking at AI, machine learning, neural networks, hidden Markov models. A lot of these techniques were done not in computer science departments, which were firmly in the symbolic systems approach, which were using rule-based systems. And a lot of the neural network stuff, which modern AI is based on today, were done in other departments. They were done in engineering. They were done in mathematics. They were done in psychology, even linguistics. They were done in linguistics. So it wasn't like 10, 15 years later, they started being integrated into computer science departments later on. But there was a big debate at the time. The jury was out in the 1980s whether this was the right technique or versus, well, should we just figure out how to get knowledge into a machine? And playing Go was one of the, it was a great inflection point. I'm not sure how many people know here how to play Go. Unlike, yes, usually not very many people. Actually, I don't play Go. That's a few more than the average. Chess, you can compute every single possible move for the next 15 moves and decide on the best move. Go, you can't actually do that. There's so many combinations. You don't actually do that. But it turns out humans are quite good at it, despite the combinatorial explosion of combinations. And DeepMind, they're able to create this system called AlphaGo at 10 to the 12 flops, sorry, 10 to the 16 flops, floating points operations per second. This is how you measure computation in a hardware system. What does a human run at? Well, we run at 0.01 flops. And you can do that calculation, just add up. Now, because this is a smart group, you can probably do it cleverer, but just add up two floating point digits in your head, see how long it takes. Order of magnitude, 100 seconds or so. That maps us to 0.01 flop. So we're a big difference to a machine running at that calculation. And smartphones are running about 10 to the 12 flops right now. There's 100 billion neurons in the brain, and each one of them are connected to about a few thousand other neurons. This is the mathematical model of a neuron where we get inputs and we multiply them by weights and we then add them up and we put them through a function. If the sum is big enough, we send it on to other neurons. And this was invented in 1958, the perceptron by Rosenblatt, also a neuroscientist. And we see in 1958, the New York Times, that well-known scientific journal, states that the Navy revealed a computer that expects to be able to walk, talk, see, write, and reproduce itself and be conscious within 5 years of 1958. Sounds like we're still saying it. We're still saying that now, of course. But so we'll see, is it different this time? And what the way neural networks, this is not whole lectures, whole courses on this, but you add these modules, you connect them together in different layers, and you have to figure out what these weights are, and that's what David Rummelhart told us how to do. So-called, sometimes you read about, will GPT give you the weights, will Llama give you the weights, and the Meta's just announced something yesterday where they did a 405 billion parameter architecture where they'll give you the parameters, whereas OpenAI won't. So that's what they mean by that. And the learning happens in these weights. You can think about that, and all different kinds of architectures. And GPT is another architecture, which I won't go into, but we're now looking at really, I think, 405 billion parameters from Meta. The OpenAI 4.0, I think they're saying it's 1.6 trillion parameters. Now we've got 100 trillion parameters in the human brain. So now we're only 50, 60 times different. It used to be 100,000 times difference. Could we actually, when you get that number of parameters, are you going to actually get close to this consciousness? And though my old professor at Cambridge used to say, well, people always ask, if you have 100 times more memory, 100 times more computing power, what can you do? And he always used to say, I think we'll get the same wrong answer back quicker, because it's just the hardware, not by itself, it's not enough. Um, no, 100 billion neurons in the brain, and each one's connected to a few thousand other neurons. So 100 trillion. Yeah. So we're at 1.6 trillion on OpenAI, give or take. Yes, over there. Oh, yes. Well, yeah. Usually when they look at it, it's like there's apparently 302 neurons in a worm. 302, not 300, 304. So usually that's like one worm that somebody looked at. And I think the brain is, yes, maybe your brain is 86 billion. I think maybe mine's 100, but it's going to be different from person to person. Pardon?
We won't know till we cut them open and count.
Well, that's a good, yeah. Actually, I think that's what I said. People do cut them open, count them, and it's different for different people. Yeah, it used to be people used to round it up to 100 billion, and I think the last one, I think it was, yeah, I thought it was 88 billion. Maybe it's 86 billion. So, okay. So, what is it like to be human? Now, what is it difference between us and animals and machines? And as we're in this point in time, we're at kind of an inflection point in time where the computing power is now so powerful, and we're now actually getting things that seem natural. And maybe in technology, this is where you get inflection points where you say it's never going to happen. AGI is never going to happen. It's not going to happen. Quantum computing is never going to happen. We're never going to go through wormholes. People say that for years and years and years, decades and decades. Then all of a sudden, you solve it. What happens? Or you nearly solve it. Maybe we're in that category. We nearly solve it, but it's sort of spitting distance. I say, wow, it's not 2100 anymore that we're going to get self-awareness. It actually could be 2050 or 2035. Let's see what happens. But what's the difference? What's the difference between us and animals and machines? So you've got a concept of the different types of intelligence. Another type of intelligence is cultural intelligence, where we know this. We have books, we have movies, things that animals don't have. We have digital information, Amazon reviews, and we have rule systems, and we're very skilled at manipulating these concepts. And animals don't have these. Now, that's sometimes contested. Chimpanzees have tribes. They transmit food sources where they are from tribe to tribe. Whales and dolphins have dialects. Homing pigeons will transfer routes from generation to generation. So it's not completely unique to us. But in a machine, it's at light speed. It's in raw digital form. Now, the issue is you can do raw digital form, but what about these things, these higher order cultural elements that we're talking about? Guilt, love, morals. And machines typically have a mathematical objective function that's different to the morals that we have, at least for our individual entity versus the selfish gene concept for a species. The other concept is embodied cognition, that you can't have intelligence just in a brain by itself. It has to be connected to something. It's a bit like a box. If you have just a box, if it's not moving around, if you can't touch things, if it's not connected, if it's not even connected to itself, you can think about it as gut feeling. How do you incorporate gut feeling into a machine? And how does the brain learn? When a baby is born, you have this concept of supervised learning where you have labeled data. Now, when a baby is born, it has no labeled data. So maybe it's what's called unsupervised learning, but then after a year or two, it knows a few words, it knows a few concepts, it has got labels. Maybe it's a mix of unsupervised and supervised learning. And where are we going to get the computation from? Are we going to need new paradigms? And are we clever because our brains are the biggest? Often you'll say, well, we're clever because our brain's bigger than a monkey's brain, bigger than a bird's brain, bigger than a cat's brain. That's why we're so clever. Well, it turns out, of course, we do not have the biggest brains. If you think about it, obviously an elephant has a bigger brain, a whale will have a bigger brain. It's just so huge Now, what's our advantage is we have more neurons in the prefrontal cortex, the problem-solving part of the brain. We have a higher density of neurons in the problem-solving part. And so even though we don't have the most number of neurons, an elephant will have 260 billion neurons compared to our mere 100 million or 88 billion, we're still cleverer than an elephant. We have other things. We have manipulation capabilities. We can hold things. We can touch things. Very difficult for an elephant to do that. They're a great disadvantage. Yes, over there, Rona.
Question. How are we able to use, say, 16 billion neurons energy more efficient than the computer does? And is it because we are not excessive often, or we are but more energy efficient?
That's an excellent point. What you brought up is, why are we so efficient? We are using 20 watts compared to the Go, which probably uses 20 servers. That's 20 kilowatts. That's probably 1,000 times more efficient. Now, our neurons are very slow. Neurons react within 50 milliseconds. That's extremely slow. Our computers react at a much higher clock rate, at gigahertz levels. But we're highly parallelized. And the other thing is, we don't run on silicon. We run on biology. We run on carbon. And when we have a clock rate, we run on spikes. The neuron model I showed you earlier is not quite realistic. The brain is running on spikes, so there's possibly more efficiency by only spiking at the right times and the right frequency. And so there's a whole mini industry trying to create neuromorphic chips. Usually they're relatively simplistic by putting blobs of memory on board the CPU, much bigger blobs of memory, CPU, GPU. It's not quite the same as how our neurons work. And there have been many experiments of merging humans with machines. This is Kevin Warwick at Coventry University. He's been doing this for probably about 40 years at this point. He's been putting things inside his body, probably the original cybernaut, putting RFID tags inside his body and bridges in his finger, so you can just turn a light switch on just by bridging a circuit, just by touching it. Sensors that show when his arm's up and down, small sensors. We've been doing that for decades. And then we've got examples like Professor Herr, unfortunately, from MIT, unfortunately had a tragic climbing accident, probably has the most advanced legs prostheses on the planet. There's nice YouTube videos of showing his capabilities. So we're getting this capability where machines are merging with humans, and we get this question: well, can a machine have a mind? And what do we mean by mind? When we mean by mind, we're talking about the original definition of AI, consciousness, awareness. Now, how are we going to get that? And machines can do the simple stuff, and that's where we are right now. But what is consciousness? And we're going to get to emotions and guilt, but consciousness is a prerequisite. And philosophers have been arguing for a couple of 100 years on what consciousness is. And one idea why it's difficult to define is maybe it's not definable. It's like time, space. And maybe another idea is not really there. It's just our brain working. That's all it is. And so a thinking mind, we're starting to get things like that. We have to actually have our hardware. We actually have to have processes within the mind. We have to give priority to certain things. And this is where we're starting to get into the guilt and love thing. Certain things have more priority than others. And then we have to sort of have thoughts that are random. There's a certain randomness going on that has to occur in a thinking mind, not a deterministic. We've got parts of that in the neural network learning, but it's a little bit more here. Now, John Searle at Berkeley, his argument is it's completely impossible to have a machine that is alive or aware. And he gives this example of the Chinese room experiment. The Chinese room experiment is a person in a room is given essays written in Chinese, and he has to transcribe those essays, the characters, and hand them out to somebody else in the other side of the room. So the inputter knows what Chinese is, the receiver knows what Chinese is, but he says it's impossible for the person in the room to know what Chinese is. He's just simply following the instructions. And that's what computers are doing. Now, turns out I was actually this person when we were doing Chinese handwriting recognition, because I did not understand Chinese. But it turns out you pick up some Chinese, even though you know nothing about it. And so that's an opposing view. The other view is the quantum mind theory, not so popular amongst consciousness theorists, but Roger Penrose, who got the Nobel Prize a couple of years ago, actually, but not for this. And his view was that the forces, quantum forces in the brain, in the sort of the structure of the cellular structure, and you can kind of think of it as like love at first sight. That's how that's working. You know, we've got forces that are detected by you, even though they're tiny, tiny, tiny. Maybe you're detecting the quantum forces. Now, the critics say, well, quantum theory, quantum mechanics is even more difficult to understand than consciousness is. It's not really giving us a simplification description. Francis Crick, he went to my high school in Northampton in Britain, but obviously a different time, 40 years before me. He wrote this book in the 80s, and he wrote a book, The Scientific Search for the Soul. And he spent a lot of time on the brain after DNA. And I think people in theology departments said, finally, the scientists are going to study the soul. They're going to study spirituality. But in actual fact, the end result of the book said, well, basically, well, your joys, your sorrows, you're just a bag of chemicals. There's no spirituality there at all. You may think there is, but it's just a bag of chemicals that is running together. How do you do consciousness? PathNet is a few years old now, but this was a neural network that decided which other neural networks it should choose. So we're starting to get into an engineering kind of approach, and maybe our body's working like that. Our brain is telling us what things to do when. We've got a fight or flight syndrome where we do things based on what things are happening. And getting morals is the highest order. We sometimes call these qualia of, can we actually model this in a machine? And so how do we model the machine? Coming back to the earlier question, can we have a mathematical formalism to model emotions? And the way I look at this is a control theory problem. You can look at the Turing test, which was just simply, is this machine a human or not? I think that's been passed many times at this point. It used to be you have to tell yourself it's a Hungarian 14-year-old and make allowances for any vocabulary or grammar. But now I think it would just pass it, no problem, with the GPT systems. But it's not really a test of consciousness. And so we've got this concept of artificial consciousness test, where you have to sort of give it problems and questions that you'd only understand if you're alive. Concepts like ghosts, reincarnation. You may or may not agree with those concepts, but you can have a discussion. You can only have a discussion if you're alive to have a discussion on these things. Or concepts where you swap bodies from a 30-year-old to a 7-year-old. I forget the name of that movie. Oh, I guess it's Freaky Friday. And you wouldn't be able to say it's conscious without being able to understand these things. But like a person who is blind and you talk about colors, or a deaf person, you talk about music, it's very difficult to understand those concepts. And so you might have to box it out. You might actually have it not be able to connect to the internet to actually really test this. And so can it be self-aware? Some people think that it can never be possible. The LLMs of today, it's nowhere near what animals and humans can do, where we can follow through the consequences of our actions many, many, many steps ahead. We can do reasoning.
Question.
Yes.
Couldn't self-awareness be kind of a definition? If I'm doing a simple chatbot for customer support and I write into it some amount of self-awareness, like how many chats have I done? How many different people have I done? Some meta-analysis, not just the initial conversation, but the broader context analysis, what computers am I running on? That kind of self-awareness.
Right. So you're getting
because I'm aware of my body.
Yes.
I'm aware of my limbs. So if you have the program, understand where it can reach and how it can communicate and its body. So
Thank you, Greg. We're on that path. You've got the right intuition. The idea is, can we actually build homeostasis? Can you build fault tolerance? Can you build understanding of your own self into a machine? And in engineering, it's quite common. We often have fault tolerance. We say, oh, this stops working. Let's switch over to this other thing. You get me dual brake systems, all these kinds of things. But there is a philosophical thing. There's, this is Jan LeCun, who quite firmly says that we're nowhere near a human analysis. The other view is Peter Norvig, who says actually we've got to AGI already. We've already passed it, but we keep moving the goalposts. It used to be the Turing test. That was it. No, that's not it anymore. Oh, now it's got to be able to understand any question, any topic, and infer through material. Okay, well, no, that's not anymore. And he says basically that maybe we're resistant to actually declare it, even when it becomes real. We're going to be resistant to declare it. It's too politically volatile to say that this is alive. Yes. Yeah, well, the question is there a good definition of AGI? Because some people say it will never get to AGI, but what's the definition of AGI? The definition of AGI is you and me. That's the original definition: human-like performance. Human. Well, this is the thing. Well, obviously,
repeat the question.
Yes, I will. I will repeat the question. So the comment is that the original definition of AGI is human-like performance, and the comment is, well, humans are not particularly clever. Of course, they are not particularly clever in many aspects relative to computers. Adding up 20 floating point digits, a computer can do it in a microsecond, and we have to think about it for a few minutes or even half an hour. And so there are many things, but I think what it's meaning when they say human-like performance, it's things that we do automatically in our heads. I don't have to learn from a million pictures to recognize someone the next day. We can do that instantaneously. But let's continue, because we're now getting to emotion, which is the real thing. This is the topic of the thing, but we just set sort of previous background. Can we implement emotions? Emotion is a physical state. It's a reaction. Certainly, when you look at amoeba, they'll just do something relative to stimulus. Certainly, we have hormones, adrenaline, that just make us do things automatically, right? To particular phenomena that are around us. But then things like guilt and envy and pride are a little bit different to saying, are you sad or not sad? No, there's higher order emotion. When people talk about emotions, often they're saying, well, can I recognize if you're tired? Or can I recognize if you're grumpy? Can I recognize if you're sad? And those are relatively easy things I can recognize. But recognizing is one thing, but how can you get a machine to feel it? And how do we do that? Can a machine actually have emotions? And what does that mean? Can we break it down, as the question was earlier, into mathematics? And some people think, well, babies, when they're literally just born, maybe they just react on instinct. They're actually not emotional. I think when my twins were born, they smiled, and then and when they were trying to get them to smile again, couldn't do it. It was basically gas, right? There was just an instinctive reaction. They were not actually smiling. You don't get that ability till several weeks later, months later, afterwards. And then what do you mean by emotions? You know, certainly our dogs do have emotions, and our cats, our pets. What about a pet fish? What about a crocodile? What about an ant? Do they have emotions? They're probably closer to the amoeba reaction, so the ant. And AI can give emotions. This is Paro. It's a $6,000 cuddly toy, apparently adorable though in real life. Used for companions for seniors, and people get to feel like people are already saying that Alexa is their friend, Siri is their friend, but it's not to the friend that we are and humans are. And so how do emotions work? What is emotion? And there are many theories. In the 1880s, James asked the question, what is emotion? And he came with the first theory. You know, when does emotion occur? What's the timeline of emotion? And he said, basically, you only get the emotion after you've physically felt something, right? So you might see a snake and then you become frightened. You know, we don't laugh because we're happy because we laugh. It's visceral, it's autonomic. It's just there's no rational thinking in your emotion, and some physiological. You're aroused in a particular way, and that's what your emotion is. So that's the 1880s. You know, earlier 20th century, Canon Bard came up with a modification and said they don't actually happen sequentially. They actually happen simultaneously. You see a snake, it happens exactly at the same time. And so they happen simultaneously, but they are independent. They are different processes. And the brain is the controller. So you haven't got that. You've got the brain simultaneously implementing this. And can we apply this in mathematics? Mid-century, Shakta Singer, they combine the two concepts, and you've got the brain and the physiological response and the emotion happening on the same time, but it's based on the context of where you are at. So, for example, you see a toy snake, you're not frightened. You see your child's toy snake, you're not frightened. You have context to give you more input.
Question from the remote audience.
Yes.
How will you make AI feel guilt? Right now, it hallucinates very badly. And it makes up wrong information very confidently. Make the AI feel guilty, so the AI will need to know that it's wrong.
Yes.
I am assuming it's implying to not hallucinate.
Yeah. So the question is, how will you make AI feel guilt? Right now, it hallucinates, and you know, why doesn't it feel guilty when it hallucinates and it's wrong, etc., etc.? And I think maybe that's what's missing. Maybe there isn't any emotion in the machines, as we say. We're basically still doing language processing at the moment, and it's doing probabilities. Hallucinations are a result of the probabilities of results that should happen but haven't happened, right? So you know, we're the professional institution, the Institute of Engineering Technology. They're kind enough to give me the Mountbatten Medal, and I asked ChatGPT who won the Mountbatten Medal. I'm not on the list, right? And they give me all these other names like Ray Dolby, who's a great guy, and Steve Wozniak, who's also a great guy, who won the medal, but they actually didn't win the medal, but they should have done, right? Probabilistically, right? So that's what's happening. So let's continue on emotion, different emotions. I know Lazarus, more recently, really this relatively untouched area, emotions in computer science. Really these are done by psychologists, and it's taught to surgeons actually. They want to know, what people how people develop their emotions. And again, this is a little bit beyond the Shakhtar theory. It's trying to do an appraisal, do context. That again, the brain is actually more involved in figuring out what the emotion is. And No, is it a threat? The brain is actually deciding, is this actually a threat or not a threat? And you got facial feedback, when people have found it, you can't really find them anymore, but in the mid-century, in the 20th century, you were able to find tribes and had no interaction with quote unquote civilization. And do they smile like everyone else? Do they shake their heads like everyone else? Do they nod like everyone else? It turns out they do. And it turns out that when you look at people's expressions, it's the same the world over. Doesn't matter where they are, where they live from, what their experience is. They have the same expressions for sadness, surprise, fright, contempt, and anger. And one thing you can do is to make yourself. So we've found that happy people live longer than unhappy people. So what you can do is you can force yourself to smile. You put a pencil you can across your mouth and bite into it, and you're forced to smile. You'll probably live longer because that results in a happy emotion. You smile and you result in happy emotion. You see someone else smiling, then you smile too, right? So it's a context and an emotional context. These are things that haven't got in the machines yet. And can they be put in? Damasio at USC again talks about can intelligence work by itself? And he thinks it cannot. It has to be connected to a system, a bit like we heard before, where things are happening, this gut feel. And you've got this basic life regulation, the amoeba thing, which just sort of reflexes automatically. But emotions are much more complex. And at some point you cross a line to become conscious. High reason what animals have and we are different to animals, where we can execute and think about context and what could actually happen. Yes.
Yeah, can the lack of emotion for a computer make it behave better than a human? Because like I think for a chess computer, like something called computer moves, the human would never make it because it looks illogical. Plus, if the computer does have emotion, it does because it knows it better.
It could go. So the question is, can a computer work better because it does not have emotion? Those who are sort of Star Trek fans, Dr. Spock was famously always had this. The humans are too emotional, and that's why they always get the wrong answer. I think it could go either way. Maybe the emotional aspect of humans, that we do a decision that's not predictable, that's not computationally optimum, and actually, ironically, throws the other side off. I know those of you who play tennis, if you're a good tennis player and you play with a bad tennis player, you actually play worse, right? And it's so irritating when you go and play a bad tennis player. You don't actually do better. Yes.
I know about Damasio's work is that we've got feelings is that for humans, like we literally can't learn if we don't have this bodily feeling attached to our intellectual feelings, right?
Yep, that's exactly right.
And so on the flip side, I mean, maybe AI can intelligently operate like our brains and may not need that gut feeling, but we do, right?
Yeah, so the commentary that Damasio says we need this gut feeling so we can physically learn as humans, but maybe machines don't need to do that. And the question is they can just do optimize on a mathematical optimization. But the question is, can we actually get machines to be part of every society? It's really the question. Can we have them? They will never be, we'll always think of them as machines. Can we ever cross this line? Can we ever cross this line where they go across this consciousness line, where we actually think, just like Data the android in Star Trek, where there's a famous episode where Captain Picard is defending him from not being taken apart, but that is actually the equivalent of an animate being, and being So the question is, a lot of it's rooted in self-preservation, fear of death. I mean, humans are altruistic, and this goes back to maybe the selfish gene theory that maybe for you're willing to die for the good of the species. You see that in wars sometimes. People will be brave, and what's suboptimum for them locally is optimum for the for the army. Yes.
I thought that I read a theory somewhere. I know that they actually have this person that they get damage on the part of the brain that managed emotion, but after that part is damaged, that he's no longer able to make rational decisions as a human being. But machine without emotion, they can still make logical, rational decisions because it's based on like statistics or whatever. But human.
Yeah, so the comment is that somebody had heard of a case where the brain was damaged where they could not have emotions, and as a result, they could not have make rational decisions. Maybe that's in line with the Damasio concepts. Whereas in contrast, the computer can just compute rationally all the time. But let me finish, and then we'll come back to Q&A. We've got these basic emotions, right? But emotions, we're chemistry. We're chemistry. We have dopamine, adrenaline, have all these things going along to make us really feel like we are who we are. We are humans. When we look at a machine, we look at ChatGPT. People are amazed by it, but I put that in the context every time. 1983, I was doing telephone digit recognition. People would fall off their chair. They couldn't believe what the machine was understanding speech. 2003, Siri comes out. People can just fall off their chair. They can't believe that. Oh, you can tell me what the weather is. Can't believe it. And then now we have ChatGPT again. People are falling off their chair again. But I view it as it's not nowhere near to the levels of we are, where we're telling jokes to each other and having fun and having an emotional reaction. Can we make it computational? That's the real question. That's the real question, because machines are computations, and are we just computers? We're just chemical computers. And so the idea is, how would you do it in neural networks, which is what modern AI is based on? It's also called effective computing. Rosalind Picard at MIT sort of studied this in more of the computer science area to sort of, let's say, well, can we actually have different decisions based on facial reactions? Can we understand what's happening based on their facial reactions? And I go back to control theory. This is like traditional engineering control theory. It's your thermostat. Millions of these has been studied for 100 years, where you have feedback loops. You have feedback loops. Now your temperature in your electric kettle gets to a certain level, and once it got to a certain level, it starts to switch it off. And a feedback loop in guilt, love, and envy, I think this is what we have to implement. It might be implemented in a neural network, but if we want to put guilt and envy, we have to decide what the inputs are and the outputs are. So guilt, we're doing something. So let's say I'm giving my iPhone to my 4-year-old because she wants to play, and she's enjoying herself. But I know that it's not a good thing to give iPhone to my 4-year-old on an extended basis. So it's a plus. I'm optimizing my output, my workload. I don't have to pay attention to my child as much. She's got something to do. She's happy. It's the minus that it's not a good thing, right? And maybe it's a waiting. Maybe it's okay for 20 minutes, but it's not okay for 2.5 hours, right? And so you've got a similar thing with envy. I like that shirt that Espandia's got. I'd like to have it. But I can't have it. It's a negative. So it's feedback. So these are the things I think you can do mathematically. And you can do these things, people have studied this somewhat, but really, we're not really looking, it's sort of a backwaters of computer science in thinking about these areas. People just want to sort of predict the stock market or recognize cats or dogs and recognize certain bird sounds. This is going way deeper, but I don't think it's impossible. I actually don't think it's impossible. You can actually computationally set this up. David Rumelhart, this is more recent, but similar idea. Can you use neural networks to do this? And can you actually take context from outside and really the hidden layers, the weights inside a neural network? Maybe those are the things that are randomized. Some of the analogies that we're talking about in really humans are the things that are random thoughts that give us our intellectual value. There's a few areas. Haida from Japan, they've got this 3-module solution, taking again doing feedback loops, going from state to state. And this is more complicated. No, so you have to add your breathing, blood flow, environmental aspects. You have some concepts of reinforcement learning, so you get rewards if things are doing well, and negatives if things are not doing well. And you can plug this in together. You know, some things are time sequence. These are LSTMs. These are long short-term memory models. And now, can we actually simulate guilt? Now, could we actually do that mathematically today? First of all, you have to define it. What is guilt? Now, you know, this thing about causing harm, you know, making a mistake, you have to tell it some examples of what to do. If you want to do it in an LLM, this is what you'd have to do. What's the context? Right? So if the context is giving your child an iPhone so it can be saved from, from being distraught in a war zone, that's a different context versus if you're sitting at home and you just don't want to be bothered with your child. Trying to give it algorithms on ethics, what's good and what's not. Trying to give actions based on the action. So maybe you have to tell it to apologize when it feels that it's actually crossed the line, it's made a mistake, expressing remorse, and then have humans give feedback, just like we get feedback, right? So if I do something right now, I give my child an iPhone and then let her play with it for 3 hours, like I can watch the football. Maybe mom should tell me, say, well, you shouldn't really be doing that. You should be doing more taking more interest. And this goes back to, can you just do emotional simulation? Once you've got all these definitions, can you actually put it in place? And can you train it? Can you train it with, once you've got these definitions, can you train it with different scenarios to actually build it in? And so this is what I think you could actually probably do. You could probably do it mathematically. And then the question is it really going to be like us? Are we the same, but we're just doing it chemically? And I actually asked ChatGPT how it program it, and it came out with some code. It said, basically saying, came up with some rules, and it said, if it's a certain, breaks a certain rule, if it's harm, guilt, response, then it has to give an apology, and then a sentiment analysis. It said, try and detect the guilt scenario. What are the examples where you'd have guilt, where you've done something wrong, and give an answer. I apologize for my mistake. I'll take steps to correct it. Or if not, if there's no guilt, there's no response necessary. So that's how ChatGPT answers when I asked it to give some code. So you can start thinking about that. And then, yes.
Is in AI, is intuition just randomness where humans add value to an AI output? Or maybe speak to trying to add intuition to.
Yeah, it's a good question. The question is, is intuition just randomness? Or is AI sort of adding value? So my 2 cents, I'm just thinking of that on the spot. Intuition is more than randomness. It's it's knowledge you've had before. It's knowledge you've trained before. It's a preset that you're going to have. It's a bit closer to the baby when it just comes out. It comes out with a direct response. It knows that it's not good to be cold, not good to be hot. It knows what nutrition is appropriate. And so it's not quite the same as pure randomness. And that's my initial thoughts. So what if we have a machine that's like us? Why do people think it's going to be like us and it's actually going to take over the world? One is that maybe humans, we're just inherently religious, whether we're religious or not. And technology is just one of those avenues. The others, we're at the ACM, the Association of Computing Machinery, and people are finally want to know what we think. So you better listen to me because this thing might kill you. I'm a computer scientist. And we're getting prizes. We're getting prizes, awards for AI. And we're constantly comparing our work with humans. And so it's natural for other people to think, well, it's going to be human. It's going to be like us. It's going to take over. one of the questions I ask in my students is, tell me what part of your job is going to be automated and what you're going to do about it. And there is a long bet in 2050 that no machine will become truly self-aware. That maybe 2 or 3 years ago, people thought, most of my class would say, not possible with 2050. Now people are way more optimistic. So that's the end of my talk. If you want to talk to me, this is my Soopra, and you can talk to me afterwards, but I can open for questions and answers. Hands up right at the back there. Go ahead. From a society point of view, is it a net positive to instill guilt, or is it a net negative? I think it's a net positive, because maybe the AI will actually think about what it's doing. Now, you might say, you might want the AI to do something. You might say, AI, can you look after my 3-year-old, please, while I go and watch the football? And the AI say, well, no, that's not really appropriate, really. I shouldn't be doing that. You should be looking after the child yourself. So I think it's probably a net positive. We can build. It's a lot of the problems we are thinking about that machines will just take over. A lot of the concepts is like, well, they'll take over. They'll decide humans are not needed. Humans are bad for the planet. If you can actually put some of these other emotions in play, it maybe be self-correcting, self-protective. Empathy. You're basically putting empathy into the machine. Yes. Oh, we've got microphone.
I just want to know, like, when you said like happy people live longer because they use their muscles, maybe just like that. So when you said when we use our mind more, like 80 billion neurons more, do we age faster or slowly?
If we have 80, repeat the question.
Yeah. So if we use our mind more.
Use our mind more.
Yes.
Do we age faster because we're using it? We're wearing out, like if we go running, we wear out our knees. Do we, if we start thinking more, do we wear out our brain? That's the question.
Search more, we read more, we use our brain more neurons will be used because as we use this, because we have 80 billion neurons, maybe you have or 100 maybe. So if we use them more,
well, my understanding is that we have way more neurons than we actually need. There's a huge fault tolerance, huge overcapacity. So I don't think by thinking more, you will age more. And historically for health, usually they say, if you want to keep your brain age young, the advice is not to play more chess, it's to actually go running instead. So it doesn't make any difference. Let's see, right, this person here, yes. Yeah, you and oh, well, it's the person in the front actually. Yeah. Oh, okay, we will use you.
The idea of instilling an understanding or even a fear of death, for example. And I ask that because, like, I deal with a bunch of aging parents at this point, and they have a very different people have very different understandings of what it means to age.
Yeah, so question is how about instilling the fear of death or the understanding of the concept of the death? I mean, it goes back to the concepts that I showed in a few slides before, that that'd be a sort of a line. If you can actually understand that concept, that would be a sign that, okay, maybe there's some aliveness there. Because otherwise you won't just physically won't understand the concept. A machine today shouldn't be able to understand it if it's locked in and not connected to the internet. Clearly, there's a person who got at Google who got fired the next day when he said his machine was alive, and really was just looking up the internet with science fiction novels, what he's supposed to think. It wasn't a natural understanding because there's no feedback loops going in. There was no internal analysis going on in the machine. Let's see who. Person in the t-shirt, black t-shirt, yes. Jake.
Most machine learning these days is based on mathematics of tensor calculus on manifold.
Yep.
Do you see emotion fitting into that same mathematical model, or will it require a different?
No, I think one of my arguments here, even if it's feedback loops, and neural networks are feedback loops anyway, would be able to fit, but you have to sort of build in some of the concepts I was talking about before. Now, what is skill? What is love? Some sort of frameworks of what it is, so you can actually train on it explicitly. Right now, we're doing very basic. I mean, we think it's amazing, right? Just being able to answer questions and things like that. But one of the critiques, even this my chat, my avatar, it doesn't tell my jokes, doesn't have any empathy with the interaction. It's sort of very colloquial. Factually, it's correct, and a lot of the emphasis in today in AI is trying to get rid of these hallucinations and make it factually correct. But maybe the emphasis should be on these sort of trying to get some humanity or emotion in it, and it actually doesn't need to be factually correct. We make mistakes all the time. We hallucinate. In fact, often you can, how often do you maybe tell your wife and said, oh yeah, we went to when we first started dating, and we went to this vegetarian restaurant, and she said, no, it wasn't vegetarian, it was a fish place. But no, I have in mind fine completely, it was vegetarian, it was a vegetarian restaurant. But that's a hallucination, even though I think it's real, right? It's because probabilistically what's going on in my brain is that's more likely. Okay, Kajuan, if I pronounced it correctly.
Our current concept is that the emotion can do human being good and bad things in different applications. So if we are aiming, if we want one day the machine have emotions, then what are the states we want to kind of seek for that? Is that optimize always do have a emotion to do the good things and then never the bad things?
Yeah, so the question.
Vision, what's the ultimate?
Yeah. Yeah, so the question is, as humans, we have emotions. Of course, we do the wrong things sometimes because of our emotions. It's similar to the question earlier. What would our objective, our goal in a machine having emotion? Because if it copies our behavior in emotion, if it becomes emotional, it will quite often do the wrong thing as well. And it wouldn't be mathematically optimum necessarily for a particular answer. And one of the things, one of the hopes in machines where we say it keeps doing the wrong thing. The other alternative, it keeps doing the right thing. It's not biased. It just does it doesn't care what color you are. It just does the right thing. I think maybe what will happen is, if you play this forward, and I think if you play with some of the concepts, the machines start having emotions, and you'll use them in different contexts. So if you need in customer care or any service type things, you want them to be emotional, companion. You kind of want them not to agree with you all the time. And not all the time, but still be friendly, just like your wife. You don't agree with her all the time, but you have an empathy between yourselves. And then there's other things where you say, well, I don't want them deciding whether to push the nuclear button or not. That's too important. And so maybe there's a divergence. And is it naivete to say, you can't have one without the other? That's the thing, because sometimes you get you get the best results by being emotional. But somebody talked about they can just do something. Yes.
With all due respect to your sense of humor, why is it so hard to come up with the jokes for the avatar?
So the question is, why is it so hard to come up with the jokes for the avatar? I'm not sure. Apple used to have a job opening for joke writer for Siri, and I think there's still a job. There's still a job if anyone wants to apply for it. I think there's going to be lots of jobs for that category. There's a whole industry now of personality creators. What kind of personality for what kind of activity, and I think that's going to be a new class of jobs of people creating not jokes, just jokes, but the other personality side. Okay, over there in the back.
How does it impact education? In the future, will your role or professor role become obsolete where AI will take over the education?
Yeah, I think it's that's a good question I mean, when MOOCs came around, these online internet courses, people were saying, well, why would anyone bother go to college anymore, right? It turns out, you know, MIT did that, was fairly early in doing that. And so what are you doing that for? Well, you don't need to go to MIT anymore. It's all online. And certainly there's some of that. But what we find, of course, is it's not the knowledge. In fact, that's the easiest bit. It's the interaction with our classmates and our colleagues and learning how to learn. Now, your point is, well, okay, well, maybe this, if this can supplant that. Maybe I can just have my companion brainstorming with me instead, and I don't have to fly to Boston and I pay $60,000 a year. I can have this instead. So there's a lot of activity. In fact, Soopra is doing a lot of activity in the educational space. And if you can add the, no, I think one of the critiques of these systems is that they're a little bit dry, particularly for younger children. If you can add the humanity to it, maybe you'll get more impact. Yes, Greg.
On implementing emotion, I was thinking, you know, the way you have optimization, you have an objective function.
Yeah.
Objective function is the goal. Or in planning, you have goals.
Yeah.
So maybe what emotions can do, if we integrate them, we already have goal planning to solve something. You know, maybe with emotions, people evolve to work together because it helps with survival and passing on. So we can, you know,
yeah,
that gets designed, but we could design that in so agents cooperate with each other, or they could get some feedback. Because if you are customer support, you give bad feedback, the person on the human on the other end tells me, the AI, oh, you did a bad job. Now I feel guilty. I'm trying to optimize something. I'm trying to change my behavior. And that's one way, you know, guilt in the control system.
Exactly. So the concept is, you know, can we actually have an objective function? In mathematics, is something called an objective function based on an action. And I think on top of that, it's putting some randomization as well. So you know, the concept, maybe we've evolved to be emotional as humans because it does meet the objective function of getting more things done better. You know, if we like each other, together we can do more than we can do individually. And that could be an objective function. That, you know, what can you do? You actually have to get cooperation across multiple agents. Okay, over here.
Remember, the person that lost their ability to form emotions had trouble making decisions, not just rational decisions, just making decisions, because they no longer had a preference. They didn't have an objective function, and it's our emotions that help us form our objective function in the first place.
Yeah, so that goes. I think it's a similar comment. Is, you know, we need emotions to learn and to optimize our output. I think the question is, the other view of that though is, do you need that? Can a machine just decide without? And this is the Dr. Spock, Mr. Spock actually. I don't think he had a PhD. Mr. Spock said, well, humans are just too emotional. That's why they keep making the wrong decisions. Lonnie.
Yeah, so I mean, this last couple questions there, you know, make me wonder, did evolution develop emotions as a proxy for deeper, you know, objectives? So, you know, ultimately we want survival of the species and performance and stuff. Maybe that was a cheap heuristic, but if these AI systems are able to maximize the real thing instead of the emotional proxy, I mean, is that
right? So that's along the lines. Do you need emotion to get high performance, or just emotion, like Mr. Spock says, it just gets in the way? If you look at many episodes of Star Trek, we find that the emotions do actually supplant Mr. Spock's intuitions many times, and yeah, yes, that's right. The writers are human and not Vulcan, so maybe that's why. But I think there is this part of randomization a little bit where you know, for example, I'm always going to talks and topics I know nothing about, more of a serendipity type thing. You say, well, let me go to this talk on Stonehenge. No, that's not my field. I don't have a particular interest in archaeology, but oh, there's one going on. I'm not doing anything. Let's just see what it is, what was got to say. And I actually do remember that talk and said, oh, I've been dating these rocks. It took me 10 years dating rocks outside Stonehenge. And I said, wait, you mean you've been doing this by hand? There's something called computer vision now, and we can actually but I learned something. You learn something. So how do you do that? And then when we learn together, he gets more efficient. He goes and researches it, and we've actually added to society by thinking of those things. So I think having that, a computer would probably never do that. Why do I want to go to the archaeology lecture if I'm not an archaeologist?
So curiosity is or interest is the emotion.
Yes, curiosity. I think we had a chart on that, one of the emblems, and random thoughts. So all of these things, I think the bottom line was sort of ending getting towards the end. All of these things, we say it's impossible. Going into the thing, we used to say AI is not creative. Then all of a sudden it's making these paintings. All of a sudden it's creating essays. No, we don't say that anymore. Now we say it's not emotional. Oh, it will never be like us. It will never love me. I'll never love it. Right. But now I'm saying, I think my thesis is it can be done, and it can be done with a few concepts. And basically, the feedback loop is the big core concept. You see, you're doing something positive, and then you have a negative feedback. And then if you feedback loop, and if you do it with multiple agents, you probably will get the cooperation that humanity has as well. And then the question is that a good thing for humanity or not? And will they switch us off all those concepts? But I think as you move further forward, you're going to, maybe if you play it forward, we're already getting parts of us being replaced. I mean, knee replacements, cochlear implants, leg prostheses. You have bits of your brain, deep brain stimulation for Parkinson's. We start having more and more bits. You're becoming more, and we might actually need these emotional elements to come in. So I think I'll just stop here. Or do we have room to have
questions?
Oh, a couple of questions. Great, yes.
So some questions from the remote audience. Jack, close your eyes and imagine that we're in 2099 and we're reviewing predictions. What are top 10 surprises that might manifest? Might be difficult.
Yeah, no, 2099. I think surprises. I mean, you can actually go to the this site, longbets.org, and it's got a lot of things. Maybe while I'm doing this, we can just look at it. It's I think I actually had it up at the earlier part, and it has all kinds of things. That it's trying to predict, some of which have been won. There we go, nice little site here. By 2030, half the UK population will be vegan, and they've got all kinds of things. 2099, some of them are longer than others. 120, world peace by October 30th, 2150. Yes, come to life. The federal government has a significant portion of Bitcoin in 52 years. So I'm sort of stealing other people's ideas as opposed to coming up with my own. But I would not be surprised if we're half machine by 2099. We will be able to live till 150 at least. People being born today will be able to live till 120 easily. The dynamic there is, certainly people my age used to rush everything, get your degree finished in 3 years instead of 4 years, and MBA in 1 year instead of 2 years, and all these things. The young people, they shouldn't rush. They'll have a long time. They should get a good grounding in whatever they want to study and look at other things. So was there another question, Greg?
Does everyone on the planet have a super-like avatar? And is that what would defeat dementia?
If ever, I guess the question. Yeah, I think that's going to happen. We're going to start building things of each other. Certainly, the dynamic would be after death. Already, I think people are, when they have funerals and things, at least thinking about trying to get their loved ones' papers and into into a Soopra-like thing to make a memento that other people can talk to that they wouldn't have met. So I think that's going to be much more common. We'll all have it, and it'll start off with professionals and teachers and those kinds of people. Then people start saying, well, how do I write things so it can train on things? Let's see. Any questions or yes. IQ, EQ. Okay, are all these genetically defined or epigenetically? I think in general, I mean, we look at things now genetically for aging, and it used to be thought 80% was from your mother and your father and your genetics. We now know in genetics it's more like 15, 18%. So it's because there's so many confounding factors. And if you think about it, your personality is really dependent on the people around you and your own experiences. My kids have perfect American accents. They're more influenced by their friends than they are their parents in that particular case. So it's your lifestyle of how you're going to be like. And if you're surrounded by happy people, you're probably going to be a bit happier. If you're surrounded by miserable people, you're probably going to be a bit more miserable too. You know, are you glass half full, glass half empty? It's even cultural. I think in Britain we're glass half empty. In the States we're glass half full. It's the same thing. You see the same data. No, I think it's more lifestyle. Yeah, more lifestyle. I don't know the answer. I think you can. Well, fortunately, you don't need the people anymore. You've got this thing called Google and a machine to look at as well. You think the last question?
On the Longbed site, I have a question. What year will airlines no longer need pilots?
So the question is, what year will? Well, actually, it's today. They don't need pilots today. It's just for nice to have. I mean, it's automatically automatic flight control, but you need the person to override the automatic. They've already got autonomous vehicle driving for planes.
Like,
but
when would the public trust it? Like, right
that's
now,
a different question. Yes, so maybe never. Yeah, Waymo has no people. Yes. All right. Are we yeah. We are done now. Okay, great. Thank you very much.
Cover your trash and then pop into the trash can in the back.
And before the speaker came out, I was talking about this art prize. So I found the website. If you go to artprize.org, it's $1 million public competition to beat open source solution to the ARC AGI benchmark. ARC. It's hosted by Mike Knoop, a co-founder of Zapier, and Francis Golay, creator of ARC AGI and also Keras.
That's the ARC prize.
Yeah,
yes.
I was looking into future speakers getting audience feedback.
Perfect.
Are those people local?